going to talk about RPL protocol, and it is one of the most important protocol in IoT. So let us start with the presentation here. So in this video I'm going to cover RPL Protocol Basics, RPL Terminology, RPL Control Messages, DODAG formation. Now let us start with RPL Protocol Basics. So RPL protocol is a routing protocol for low power and lossy networks. So low power in sense, here the devices will be having a low power and the here is losing networks. The meaning is there may be the chances of losing the packets with higher data rate. So in this type of network, we are going to use the RPL protocol. This RPL is mainly used with IP version 6, but it can also be implemented in IP version 4. So it is also called by the name called distance vector routing protocol. It is based on the terminology called distance oriented acyclic graph. In short, it is called by the name called DODAG. Now let us look about some terminologies which are used in RPL. So the first one is directed acyclic graphs. In short, it is called by the name called DAG. So the meaning of DAG is it is a graph that contains no cycles or no loops. If I take the first one here, we have some 5 nodes. If you see all the 5 nodes, we don't have any cycles or loops. So from 1 to 2, from 2 to 4, we don't have any loop here, and from 1 to 2 and 1 to 3, here also we don't have any loop. And if I take 2, 4, 5, there is no loops. So there should not be any closed cycle, there should not be any closed loops. If you take the second one also, if I take A, B, D, from A it is coming to B, from B it is coming to D, but from D it is not going to A, but A to D is there. So there is no closed loop. If you take A, C, D, so from A it is coming to C, from C it is coming to D, but from D it is not going to A, and hence there is no closed loop. And if I take A, C, E, from A it is coming to E, from A it is coming to C, and C to E, but from E it is nowhere going to A. So there is no loop. So this is the example of DAG. And if you take the third one, A to C, A to D, D to F, there is no loop here also. And here also E, B, D, G, I, H, there is nowhere loop here. So this type of graph is called directed acyclic graph. So next terminology, that is root. So root, it is a destination node of DAG. It has no outgoing edge. So it is a root. It is the destination node of DAG. DAG is nothing but what? It is a graph that contains no cycle or loops. Root means it is a root node. It is a destination node of DAG. It has no outgoing edge. From root, there will be no edges. There will be no path actually. That is called root node. And up, it is a edge that is directed towards the root node. For example, this is one up edge, this is one up edge, this is one up edge, and this is one up edge, and hence I have given here the name called up. It is moving towards the root node. And down in sense, it is the edge directed away from the root. For example, if it is a root, it is in this figure, it is a root, and the path taking from root to the downward node, it is called a down link, you can say, down edge, you can say, and hence I have written down with a red color arrow. It is the edge directed away from the root. Next, DODAG. So DODAG stands for Destination Oriented Directed Acyclic Graph. So this is a special node of DAG where each node wants to reach a single destination. For example, if you take this whole graph, so here we have certain nodes. All the nodes are directed towards the top, that is called DODAG route. It is taking the path from this node to this node, this node to this node, and it is this. If I take this node, it is taking the path from this node to this node and this node to this node. And if I take this node, it is the it is taking the path from this node to this particular node and from this particular node to this node. And if I take this particular node, it is moving towards the root node. So here DODAG is nothing but the root node. This is a special kind of DAG where each nodes in the network uh, take the uh, take the path to reach the single destination, that is called DODAG. Next, we have one term called objective function. So this objective function actually helps us to decide whether we are near to the root node or whether we are away from the root node. And objective 2, it tells, it is decided by the programmer actually, or by the designer of the protocol. It is something that we want to minimize the latency as much as possible, the time taken to receive the packet, and the distance of the transmission, and the number of hops. And we have two more terminologies here. One is rank and second one is instance. So just look for the first one, that is rank. So it is the number of hops away from the root. So for example, if I take this particular node where the pointer is pointing, so the rank of this particular node is equal to 3. It is 3 hops away from the root node. So 1, 2, 3. And if I take this one, second one, so it is the rank given here equal to is 2. So this particular node is 2 hops away from the node, so 1, 2. And if I take this particular node, the rank of this particular node is equal to 1 and it is 1 hop away from the DODAG root. So this is called the rank. And instance, so in this particular second figure, in this whole network we have two DODAG graphs, where this one is called root 1 and this one is called root 2. We have two root nodes, and for this particular graph having one or more DODAGs, and the instances are measured on the basis of the number of DODAGs. For example, here we have one full DODAG graph and here one full DODAG graph, and root 1, root 2. We have two root nodes and hence the instance of this whole graph is equal to 2. And let us know the meaning of DODAG ID. Each DODAG has IP version 6 ID of 128 bits. This ID given to root node only, not all the nodes in the network, only the ID will be given to the root node, and it says until the root does not change. If the network changes, then the root node also changes and hence the ID will also be changed. And second one, RPL goal. So goal is, it is to provide the best route path using DODAG. The aim is to minimize the objective function so that the latencies will be minimized, the transmission distance should be minimized, like that. And grounded node. So when DODAG reaches its goal, When full DODAG is established and further no more the paths will be there, at that instant it is known as the DODAG will be grounded. So it is called a grounded. And floating means when DODAG is not yet connected or yet to reach its goal. Still it is not yet connected and it wants to reach its goal, then it is called by the name called floating DODAG. Next we'll take parent and child node. So the parent node is where the arrow is pointing towards, and child node is where the arrow comes from. So the next point is the parent node can have multiple child nodes and child can have a multiple parent nodes. For example, if I take this particular figure, so root 3, if I take only this much, root 3 is the parent node for all these nodes. And if I take this one, it is the parent node for this one and child node is of this one. And if I take this is a parent node for this particular node and this will be the child for this, and these two are the childs for this particular parent node, like that. Okay, then comes there are the two nodes. One is storing node and one more is non-storing node. So storing node is very simple. Storing nodes keep whole routing table and it is having the knowledge that how to route the packets from one node to another node. Root node is always a storing node. Actually, the top one, the top DODAG node, root node will be a storing node which is having all the information about the network. Next, non-storing nodes knows about their parents only. They cannot restore the routing table. There will be no routing table for that particular node. And let us take the most important part of RPL, that is RPL control messages. So here in this diagram we have a figure like this on the right hand side. So new node, this is old node. Let us take the first one. The first control message is DIS, DODAG information solicitation. So when there will be no announcement, actually when no announcement is done, and if this particular node wants to join DODAG, it sends the control message called DIS to the old node, right? For that it wants to know any DODAG exists or not. It will check whether the DODAG is existed or not. Is there any DODAGs? It will send that particular message, that is DIS, that is called by the name called DIS, uh, DODAG information solicitation. So next message is DODAG information object. This message is multicasted downwards. So from old node, this message will be multicasted. If they are interested to join, please let me know. So this message will be forwarded or multicasted by old node onto the network. If anyone wants to join, then they can join to the network. And next one is DODAG advertisement object. It is a request done by the child to parent node. So it is the request done by the new node here in this figure, done by the new node to the parent, that is old node, DAO. So last message is DAOACK. So it is the response sent by the old or parent to the child node. This response can be yes or no. So these, on the basis of these four control messages, the network will be formed in order to route the packet from one node to the another node. And the last information about RPL is how actually the DODAG formation takes place. So let us take the first figure here. Let me read the first point here. Root in a DODAG is a special node, this particular node. All nodes don't have the capability to be root node. A root node is programmed for it. So let us take the second point here so that it will be more clear now. Suppose we have four nodes A, B, C, D. To form a DODAG, following steps are to be taken. So the first step, node A, node A that is root node multicasts DIO to BCD. So first what will happen is, let us consider these four nodes. A node will dispatch the message called DIO to BCD. Next what happens is, upon receiving a DIO message to BCD, so what happens when receiving DIOs by rest nodes, that is BCD. So the rest nodes will be knowing, the rest nodes will be having the idea of distance with respect to A. For example, let us have x distance. B is having a x distance from A, C is having a y distance from A, and D is having a z distance from A. So after that, the rest nodes B, C, D sends DAO, right? DAO means after knowing the distance, this B, C, D send a message called DAOs to the node A. So root node A accepts these DAOs and send back DAO ACKs, that is DAO, here I have discussed DAO ACKs, that is DAO acknowledgement message will be sent from A node to B, C, D. So like that DODAG formation will takes place. First, the broadcast of DIO will be done by root node to all the nodes. Then upon knowing the distances, the rest nodes will be send their DAOs to back to the root. Then after receiving the DAOs, the root node will send DAO ACK. So another similar round will be initiated by nearest root node. For example, B is nearest. It will broadcast DIO to the nearest node, and upon receiving the distances, it will send DAOs, and the process will be followed up. This process continues till the identification of the shortest distance in the given network. With this, I'm going to conclude this video. Hope this video is informational. Please share and like the video. Thank you all.